Hello, this is another video about my game development journey. It's going to be a technical one this time, but I cooked up something that I'm kind of proud of and want to share with people. So it's about rendering text to SDL2 windows, SDL2 being the library that I'm using for my game development. So this video is not going to be like the last one where I was actually showing features that I've implemented, basic features like how the map moves around when you move your character, and menus, and going in and out of rooms, that sort of thing. Because SDL2 is not a typical engine like Unity or Unreal or Godot, you have to implement even basic features like that yourself. And that's what I was showing last time. This time it's much more technical. I'll be showing code, the results of some experiments, comparing one method and another. So if you're into SDL2 and C and that sort of thing, then you might perhaps find something in this video interesting, but otherwise I fear it might not be for you. But regardless, there's the technicality warning, and here goes. Okay, there are two ways to draw an image to an SDL2 window. You can use surfaces or textures. My understanding, I'm not super deep into how SDL2 works under the hood. I'm interested in it, but as of now, I'm not like an expert by any means. But my basic understanding is textures can be hardware accelerated, but surfaces are software rendered and cannot be hardware or GPU accelerated. Which means that if you can, your default choice should be textures because there's potential for faster rendering. So I use textures. And I got to a point in my development where I wanted to start implementing dialog functionality, which means, you have a font file, a .ttf true type font file, you grab letters, glyphs from the font file, you draw them to the screen. And SDL2 doesn't have a built-in functionality for that, but there is a very popular, widely used extension. It's called SDL2_TTF. I don't know if it's technically officially approved by the core team. It might be, it might not be. I'm not sure. But if you Google how do I render text with SDL2, that's what pops up. So, but it uses surfaces. It grabs glyphs, characters, letters from the font file, and it puts them in a surface. It doesn't work with textures as far as I understand. And that's not fatal because you can, even if you're using textures like I am, you can simply convert a surface to a texture. There's a function for that. And that's probably what most people are doing. But I might be a little neurotic. I found that a bit icky. Like, why do I have to use surfaces? I don't like surfaces. I like textures. So I came up with my own method that will grab glyphs from the font file and put them directly in a texture without any surfaces. I looked at a little bit of SDL2_TTF documentation and I saw they're using FreeType. So I'm also using FreeType, but instead of putting it in a surface, I put it in a texture, and that's the main difference. And I'll show you what it looks like. So I have some pink background just to make it easier on my eyes, doesn't matter. I'm grabbing a bunch of random letters from my font file and drawing them to the window. They look pretty clean. They look fine to me. I'm rendering 1,000 letters, but you don't see them all because the window is small. And they go off the window, but the rendering is happening in the background and that gets reflected in the render time. I'll discuss these times in a bit. And for comparison, rendering text with SDL2_TTF. I'm going to show the code for these files. And these shell files just GCC, compile, and then run the executable. That's it. So, they both render letters to the window. Mine feels cleaner to me because my method, it's working, but it doesn't have to go through the step of create texture from surface. But I wouldn't be able to justify using this method that I wrote if the performance was bad. Like if it skips the surfaces step, but regardless takes more time, then I wouldn't feel like I had accomplished anything, and I would just use the prevailing method and just bite the bullet and convert my surfaces to textures. So I did an experiment to see, okay, how's my rendering time? And it might not be the most rigorous, comprehensive experiment, but the results were good. I'll show you what I did anyway, for what it's worth. So I rendered one glyph, 2, 5, 10, 100, 1,000, 10,000 to the window with both methods. I reran the code 10 times and took an average of the CPU time. And these were the results. Now the init time doesn't really matter. The reason it's here is because I had this fear, maybe irrational, I don't know, but C can be funky sometimes. So you have some initialization lines of code like SDL_TTF init or free type, whatever. You have some lines that you run first before you can start using the functionality. And I was concerned that like maybe the initialization time would vary with how many glyphs I render. Really shouldn't, and doesn't, but C has been weird to me before, so I wanted to check. So I happen to have recorded these initialization times here, but they don't really matter. My method takes less time for initialization, but it's a fraction of a millisecond. And initialization is something that happens once when you start your game. So it really doesn't matter. You can ignore that. What matters is the render time. So when I render a glyph with the prevailing method, but also converting to a texture first before drawing to the window, I get these render times for 1, 2, 5, and so on. And when I use my method directly to texture with no surfaces, I get these times. So for 1, 2, 5, and 10 glyphs, my method was more than twice as fast. For 100, 1,000, and 10,000 glyphs, my method was, I don't know the exact percentage here, but it looks like 33% faster. So that's good, that's promising. This wasn't about an important performance improvement for practical reasons. Like, I'm going to be making, at least at the beginning, simple 2D RPGs, probably not computationally intensive at all. This potential performance benefit, assuming that this experiment, represents the reality of what I'm trying to do, it's not going to really matter, for me anyway. What it was really about was writing a method that felt cleaner to me and then being able to justify using it by seeing if the performance was fine. That's all it was about. It was just about satisfying some neuroticism of mine, not really about like, oh, my game is running too slow because I have so much text and I need a better method. Not necessarily that at all. But anyway, so that's the result of my experiments. And I'll show you the code that printed these outputs for comprehensiveness. This is the code that I used for testing out SDL2_TTF. I won't go into too much detail because the video is already a bit long and perhaps dry. I hope not. I hope it was interesting to people who are into this stuff. But I won't go line by line. I'll assume that anybody who's looked this far knows how this stuff works. But I will include like scrolling through my code. I mean, I should just post it on GitHub and then post the links in the description. But yeah, if someone's interested, they can take screenshots. Sorry, so inefficient. But yeah, instead of going line by line, I'll just like quickly, vaguely talk about certain blocks. So this is just like setting up the window, the renderer, drawing that pink background to the window. This is the initialization stuff I talked about. It doesn't, as I said, it doesn't really matter, but here it is if you're curious. These are the lines that I consider like are the rendering time for the SDL2_TTF method. So I use this to convert this long string into a surface, and then create texture from surface, some rectangles that tell SDL2 how to draw it to the window. Doesn't matter. Yeah, so these are the steps that I consider the rendering time for SDL2_TTF. And then here's the game loop. All the game loop is doing is drawing stuff to the window, so nothing special happening there. Sorry, I'm really skimming this because I want to wrap up and I don't want to get too deep, like line by line into the code. But I also wanted to show the code in the video. And my method. So this is the function where the magic happens, but I'll get back to it. And this is all exactly the same as in the other script. It's just starting the defining the window in the renderer and frame rate stuff and setting the pink background, initialization. Again, the initialization didn't turn out to matter, but it's something I was curious about while I was doing this experiment. And this is what I consider the rendering time for my method. And actually, my method could probably be improved because I actually have an individual texture for each letter, which is not how I'm going to do it in my actual game code. But I was just quickly hacking stuff together to test out free type. And I don't actually think it'll matter that much to speed. I mean, that's just my intuition. But the fact that I have a separate texture for each letter is probably a memory penalty. So I'm going to have, of course, one texture in the end for the whole string, but right now it just doesn't matter. This is what I have. It could be better. So I basically run this function for every letter in this string. And now I'll get back to this, what that function was. So I'm using free type. I get the glyph, aka the image of the character, out of the file. And I then have to kind of reformat it. I wanted to avoid this. The pixels for the glyph are all here, and I tried to put this directly here, but it rendered weirdly. It had like 4 repetitions of the same character instead of just one character. And I think that has something to do with the channels. I spent a lot of time trying to avoid this for loop, but I couldn't. And from what I'm seeing on a few different Stack Overflow discussions, it's pretty normal to have a for loop to reformat this buffer. But yeah, so I get the pixels using free type. This is where they are. I reformat them, then I put them in this texture. Then I create the texture, and here is where I put it in the texture. So that's as much detail as I'll go into for the code, because it's already a bit of a long video. But yeah, so in summary, a method for rendering characters to an SDL2 window that skips surfaces entirely and is a little bit better performant and just feels a little bit cleaner to me. That's what I was able to throw together. And yeah, I'm kind of proud of the results, so I just felt like sharing. I don't know if it'll be interesting or relevant to anybody, but here it is. I thought I would share it. If you listen this far, thank you so much. Really appreciate it.